Hello and welcome back to Basic CM4D Training. In this module, we will be looking into some detail with the creation of datasets and the various options that are available to you to configure the datasets. In the last module, we looked at connectivity within CM4D, and we saw how we could create a query, a simple dataset, an object on the white space, and connect those three items together so that data can flow from the query onto the white space. But let's look at some options we have available for data sets in detail here. So again, to make a data set, you can right click on this data set category under the DataSets tab, and we can choose New Dataset. Once that's done, you'll have a series of different tabs available for you here. So this first tab is the General tab. This is where you can name the dataset based on the type of information you plan to include, or you can have a generic name. Besides that, you can also go here to Sift Rules, and this is again where we would choose the type of data that we want to contain. So for Sift Rules, if I clicked here, I'll have a list of the different SMI types available for the features. And again, just to restate what we did in the previous module, if I go back to this Data Source tab and right click on Features and say View Features in Grid, you'll either have a grid bar down below or it might be detached like it is here. But in the grid window here, you'll have an SMI type, and again the software is telling your it's deciding for each feature in the routine which category or SMI type it fits into based off of the nominal data that's been loaded into the database for that feature. So if you notice, some of the features have SMI surface, some say whole, there's two that say XYZ, and that's due to the lack of some nominals that would put it in the surface or whole category. And then also SMI surface down below for these features. So this is showing you the various SMI types that the software is putting your features into, the categories that it's assigning. That's important here for the data sets. If I go back into this, I can double click or right click and go to Properties. If I go back to Sift Rules, the Sift Rule type here will correspond with the SMI type for a feature. So if this list of features starting at the top down to row 23, if those are SMI type surface, then the surface category here is what would decide the type of data shown for those features. Likewise for the features below that fall into the SMI surface type. All of those would be controlled by this particular area for the SMI type surface. So right now I have position turned on for that data. If I want to change or add dimensions that will show up in the data set, I can turn those on. Or since I have IJK vectors, I could do something like turn on primary here. And what this will do is give me one row for position and one row for whichever direction has the primary or biggest vector value. So it will look at the IJK values, see which one of those is the largest, and decide that that is the axis that's considered primary for surface. For hole, if I did the same thing, for instance, let's say I have primary turned on for hole, it will also look at the vectors, but since the geometry of a hole, the hole is in a plane, and that plane will be considered the secondary and tertiary axis. The primary is the axis that would be perpendicular to that plane. So it would be opposite of what you expect for a surface point for the primary. So whatever plane that the hole is in, the primary axis would be the one that's perpendicular to the orientation of that plane based off of the ij and k vectors. So if we want to see the result of that, I can choose that for those two, hit OK. The other thing I want to do here is go to data source, and in data source, again, this is where we would choose the actual features themselves. So let's say we wanted to grab those features that are surface points. There's different ways that we can do that. First, on this left-hand window pane, we can choose the particular query that we're connecting to. And then here in feature, we could go to list, hit edit, and pick individually the points that fall into the surface category. There would be more than that. I could go and choose the rest of these. Like so. That's one way of choosing the points, by picking them individually if you happen to know, either by something in the naming convention like the E or the S that tells you that the point is a surface point, or you could choose everything. Just say all features in query. Set is for creating what are known as feature sets. It's an old function within the software that allows you to create groups to use within the data sets. Instead of having a list that you choose, it will be a predefined group. But the next option would be all features in query. We can use this option, or we could say use only feature or particular feature from that query list, and would just use that feature. But typically we would say all features in query, and then here for sample selection options, we can choose the active sample. So whichever sample we activated, that would be the one sample whose data would be in this data set. We can say the last sample, that would be the last sample in the list shown in the query, or the most recent sample. This we can specify of the samples that are in the query, which one that we want to have contained in this data set, or we could say all samples in query. And again, if we choose this, all samples, we would get back everything that was in the sample list on the data source tab. If we chose here, use only sample 1 or 2 or 3 through 0, what that would do is only pick the first and second sample from that list to show up in this data set. There is, let's see, sample 1 through 5. If I did something like this, that would give me the last 5 samples. You can put in negative values here as well. or change the ordering. So for instance, if I do sample 1 through 5 and then hit OK, if I right click on this data set and then say view data set in grid, it's giving me the last 5 samples starting here. So sample 1, 2, 3, 4, and 5. If I go back into here and change this option and say samples 5 through 1, now it's giving me, actually giving me the same options here, these first 5. But if I went here and said -1 through -5, it's now giving me the very last 5 samples from this set within here. So we see there's a lot of options for being more specific about the samples that you select, or we could just turn that off, and again this would give us all the sample values or the samples that are listed here in the main query. And of course, if we changed the sample load options here to say the last 15, then this list would grow by 5 columns and display the last 15 samples, which would be listed underneath here. So this is how we can pick the type of data or the volume of data that we're going to contain in this data set. We can choose our points, choose the samples, choose the type of data, and then when we view the data in grid, you'll see the list of points in the order that they were chosen and the list of samples in the order coming from the query at the query level here. Now there are some other options that exist for further sorting in the sift rules. If I click back on the sift rules, again, if we see that we chose primary for the surface and whole, if we look in the data set, we'll see that we have different dimensions, whether it's y, x, z, depending on whichever is the primary vector for the surface point or the whole point. But if we scroll further down past the different SMI types, there are other ways of filtering out data. So here there is featured filters. This allows you to filter out particular features based off of a tag that you can assign to them through something called a feature filter. So in previous modules we talked about sample filters that we can apply to sample files as they are loaded into the system to track things such as the operator who measured the file, maybe the sample production level or area that the sample was measured, CMM or the software that was used to measure the sample, anything that a company might find relevant about the sample that they'd like to use to sort later on. Well, you can do the same thing with the features or all the measured locations that have unique names for your routine. So the one way to use that is to go here where it says sample filters, and depending on what's turned on in your database for filters, you can go to that type and enter the value that corresponds to the type of feature you want this to filter for. So for example, if I go here to data utility, in another module we talked about the functions of data utility for doing searches, for edits, deletions, and creation of data as well. But here in data utility, I looked for the routine that's being used in this example, which is this one here. I'm going to keep rows. And if I go to my feature search and get back all the features, there's a column that I brought in called type. So this is one of the feature filters that has been created for the data. Again, as a quick recap, feature filters can be created by going to this filter management icon and seeing the three main categories: routine filters, feature filters, sample filters. We can expand this feature filter, and depending on what filter is being used, there's a particular name that can be assigned to it. There's one here called type that was created, and this is an unrestricted filter, which means that if we can pick up any value from a sample file and load it for a particular sample as its type. There's no short list or defined list of values that only those can be used. So that's the case. There is this feature filter called type that has been turned on. And now if I click on type in these columns and bring it to the middle of the screen, I can assign, whether it's removing or assigning, a certain value to these different features. So for instance, I notice here for all of these that say S, I could right click and choose edit type and put another name in here. I could just put the abbreviation S for those, and then maybe H for these. Since they'll start with E, I could use E for edge. And so I'm assigning a feature filter to all of these different features, really based off of the first letter here. But it can be based off any criteria that the company or your customer deems important or necessary to capture information about these different features. So I just hit commit, and now I have feature filter values for the feature filter type for these features in the example. If I go back to CM4D, first I'm going to do a refresh. So I'm going to hit cancel, and I'm going to go to this data source tab, do a refresh. And now if I go back to datasets, double click on this one and go to sift rules again, scroll down to the bottom. For feature filters, if I go here and put the word or the letter E, like so, and then choose this must match condition, if I double click, I can say all filters specified or at least one. So it's an AND operation or an OR operation. So depending on how many feature filters you have, you can set up multiple conditions that you want to have this data set use to filter out just the features that meet all of that criteria. So in this case, I'm just looking for a feature with type E. I'm going to say all features specified. That's the only one turned on. If I hit OK and OK again, and then view this data set in grid, I will only see the features that fell into that category E that I assigned here in data utility. Just as a side note, the assigning of a feature filter value to features or to samples or to routines, that can all happen at the datasmith level. If you have that information available in the file, we can create characteristics to pick up that information and store it in the database so that you don't have to manually do this step in data utility to assign values to the feature filter. But since we have, for this example, I'm just illustrating how feature filters can be used to sort data within the data set, which might make things simpler if you wanted data sets for particular types of data or for certain groups of points. Those groups can be created automatically through DataSmith, and then using this sift rule, you can have the software do the sorting for you without you having to look through a list here by going to list and edit for the features. Instead, you can just tell the software include everything by saying all features in query, but do your sorting here in the sift rules based off of this criteria, and then for the data based off of the criteria you determine for the dimensions for the SMI types that your points fall into. So that's one way of sorting here using feature filters. An additional way to filter data within the sift rules of a data set is to use conditions, which are right underneath feature filters. So with conditions, if I double click on this, you can specify up to 10 logic conditions that the data must fulfill in order to be kept within the data set container. And you can specify an AND condition where all the conditions have to be met, or an OR condition where at least one of the conditions you specify have to be met. So with conditions, you can use variables or logic expressions in order to filter the data. This gets into CM4D variables and how those are used. Variables are different phrases in the software that can resolve or bring back a type of data that you're requesting or asking for. So there is a list of variables in CM4D. There are many, but just for the purposes of this example, I'm going to use a very quick statistic variable. So for instance, let's say that we've chosen the features that fall into this group called E that we created through the feature filter, and of those we want to only have features whose CPK value is less than 1.33. So what we could do here for this logic condition is put in variable CPK and then less than symbol and then 1.33. So let's see if this works out. If I do that and say all conditions and then hit OK, right now I have 23 rows or 23 features in the data set. If I hit OK, it looks like that drops down to 3. So of those 23, these 3 rows have a CPK that is less than 1.33. So again, we're just seeing how we can add more functions within the SIFT rules to sort or have a specific set of data that we might want to report on based on any type of statistics you might want to supply, based on the type of feature it is, if you have information through a feature filter and through the data values themselves, because this is based off of primary vector value for the surface and hold data that our points fall into. So we could add many more of these. There's ways of creating phrases or algebra expressions within here as well. Those could be added to this group, and it would have to match all of those conditions, fall under this particular feature filter for the values that we specified above in the SMI type rules in order for its data to be included. And then right underneath conditions, there's also something called sorting. This allows you to sort the values according to, again, some CM4D variable that you want to specify. So in this case, I told it must match CPK less than 1.33. To get more values, let's say greater than 1.33, so that I get the rest. So now I have 20, and it looks like it's sorting according to how the points were in order from the query level. So 1, 2, 3, 4 down to 23 for this. But if I go back into the SIFT rules and go to sorting, let's say I want to sort by CPK. Then if you notice, this list has changed. It's now sorting not according to the numerical order of the features, but by whatever the CPK value is. I believe it's sorting from the smallest to the largest. If we wanted to sort the other way, from the largest to the smallest, we would have to do a particular expression like this. CPK times, parentheses, -1, closing with another fancy bracket. So now I've just created an algebra expression multiplying this by -1. In terms of the software, this means sort the inverse for the CPK. So go in the opposite order. So if I did that and hit OK, it would sort the opposite way. So in this case, I think it's going from largest to smallest. And then finally, if we also add this mechanism to keep only top values, after it does all of this sorting, if I double click on this, I can say show all the values, which it's doing, or show top number or top percent. If I say top number, I can specify here, out of whatever list is generated, how many rows do I want to keep. So in this case, if I did 5, it would now sort the top 5. So in doing something like this, you could create a data set that contains summary information about a certain group of points. And that summary information is based off of sorting due to some statistic that you're looking for. Again, these are a lot of options that just give you the power to organize your information into different groups based on what it is that you want to report. There are many, many different combinations and ways of using these different functions that are being shown, but I'm just trying to provide a somewhat easy example to illustrate each function and how they can combine to show a particular set of data. So finally, there's something called hide show as part of the SIFT rules. If I double click on this, you can hide certain rows of data in the data set. So I could choose to hide rows with no data. So if an entire row is blank and has no information, we can turn that off and tell it to hide that row if every sample or column is empty for that particular feature. And then we have some other options. A lot of these will be covered in other modules. For instance, the hide rows that contain an alignment datum. There's an alignment module that can be done to create virtual datums and reevaluate your measurement data. That will be covered in another module. But for this particular session, I wanted to just look at show only rows triggered by event 1 or by event 2 or by events 1 and 2. These three are referring to events that are set up within the data set at this level, this event tab. So the event tab is where we can create logic conditions that all of the data inside the data set will be compared to. So here we created logic conditions in order to sort or to filter data. Here in event, we can create two logic conditions called trigger 1 and trigger 2, which will evaluate our data against these conditions that we create. For example, if I said value greater than, I can just specify a number, and any value of these cells in this data set, if it has a value greater than 2, well, the data set would simply flag that particular data value. And by flag, it just means make note of. So if it did something like that, we could flag that value, and then later on, if we go to our SIFT rules where it says hide show, if I said show only rows triggered by event 1, then if that row had a value that was greater than 2, that row would be triggered, and that would be one of the rows that show up, whereas all the others would disappear. So if we look at this, we have many different logic conditions that we can set up, and besides using just numbers, we can also specify variables within here. So we set value greater than maybe the mean. If we typed in mean here, we could do something like this, or value greater than the UT, which stands for upper tolerance. There's many different techniques or ways that we can use these different triggers to, again, tag the data later on, either to use in accordance with the SIFT rule here for hiding data, or in other cases if we wanted to do some sort of conditional styling later on in other objects. But event tab is basically where those conditions would get set up. So one thing that we could specify is a trigger called out of tolerance. So if I did that, out of tolerance, and then go back to general in a SIFT rule, if I turn that on, then this would only keep any row that has at least one value that is out of tolerance. So if I did something like that and then hit OK, well, in this case, none of the values are out of tolerance, so I have no rows showing up. But if there were, then I would only get the row where it had at least one value that is out of tolerance. So again, there's many different ways of using the sorting mechanisms within the SIFT rules to get a very specific set of data if you're looking to report on a particular issue or statistic. So we've gone over many things here in the General tab in the SIFT rules. There's also the ability to use what's known as multiple SIFT rules. So everything that we did here for these values is to filter data in one SIFT rule set. But you can have multiple SIFT rules. So if I turn this on and then click SIFT rules again, this case I'd start from scratch again. I can add in a SIFT rule, call this rule 1. Let's say we call this edge data. So with this turned on, this would be the first SIFT rule. If I edit this, again, I get that same list. In this case, I can edit this, and then for the feature filters, just choose the type E. And then if I hit add, I could create another SIFT rule within here, say whole data, and whatever this doesn't contain, this would filter out the rest of the features. So this would grab the features that fall into the category E. If there are other categories left, and I do this SIFT rule, I can have this try to pick up points that are just for holes for the feature filter H, or any other, again, any other filtering criteria that you specify. But the point is, these get applied sequentially. The software will take a look at all the features that are in this data set and apply all the SIFT rules that you created for the first one. Once that's done, it will take the rest of the features and apply SIFT rules to filter those out according to this criteria. And it'll keep doing that for however many SIFT rules you create. The whole purpose of that is really to work in harmony with a function called auto reporting, which will be seen in another module. And auto reporting, it allows the software to do an initial layout for all of the charts or objects that you're going to create on the white space to kind of save time if you didn't want to manually sort the entire order in a data set using the list. You can create these multiple SIFT rules, and then later on when you did the auto report, the software would sort through all the values, find the features that fit this criteria, make pages for those. Then it would stop the auto report and create a new page and start for the next rule in the list here. So in doing that, it might make it a little easier to keep the different categories separated for the reporting pages, and make it easier to modify those pages, make the changes needed, and create a finished report. So this doesn't have to be used, it's an option, but if you did, that would be one of the primary reasons to use this. And we'll probably see an example like that in another module for using auto report and multiple SIFT rules. But when we turn that off, then the original rules reapply. Those settings aren't lost, but they just get applied back. Now, also on the General tab, there is some additional processing that you can do to do more manipulation or sorting of the values in a data set. To do that, first I'm going to go here to the sift rules and turn off a lot of the sorting here so that I can get my complete list again. So I'm going to hit OK. And if I view this in grid, let's see, I think I will scroll down, turn this off, this high value, make that 0 again, or actually just say no top value, show all. So now I have my full list again. So if I go back into the data set by double clicking, I have this additional processing. This allows you to do other types of manipulations to the data. So for instance, I can click on Transpose, and what this will do is change the rows into columns and the columns into rows. If I do that and hit OK, then as you see, it transposes the data within the data set. That can come in handy if you're trying to do some sort of statistic or summary on entire samples, which now are in a row, and you could do some sort of system variable to calculate some data for each sample. The one thing to mention though is that when you do a transpose, you will lose information for the features themselves. So the data becomes more like individual values instead of structured feature object with nominals associated with it. So what this means is that when you transpose information in a data set, you would probably lose the ability to use variables in a chart in order to recall data for it. But sometimes it's necessary to do this operation if you're trying to compute some particular statistic or manipulate the data in a step to get to what it is you want to show. So if I go back here, I can turn that off. So that's one option. Another is formatting. With formatting, you can specify maybe a variable or a number that you want the data to appear as. So if I put in, again, the number 2, all the values get replaced with 2. If I change this to a variable, there's a variable called $ERR, that stands for error. What this will do is give me back the difference between whatever the deviation is and what the nominal is, or what the actual is. And actually it'll give you the difference between the measured value and how far it is away from one of the tolerances. So if a value is out of tolerance, this will tell you how far out of tolerance is that value. So if I use this and hit OK, for some it doesn't apply because there might not be tolerances for those values. So what I'm going to do is change the sift rule back to position. And I guess I'll keep that primary. Looks like that still doesn't apply here. So let's see, if I view this in grid, I see I have position data, but I don't have tolerances. So everything else seems to have tolerances. I'll go back to my original plan, specifying the primary and primary. If I view that in grid, looks like it's not being generated there. But there's other instances like this where you have the value 0. That means that the error is 0, that these values are in tolerance. So basically, if this was working correctly, if the value was out of tolerance, it would tell you here by how much is that particular value out. So it's just one type of variable that can be used there. The other thing you could do is maybe an expression like this. What I'm doing here is saying give me the absolute value of this. This between the two tildes is a variable that is referring to the actual data in the data set. So all I'm trying to do is apply an absolute value function to give me just positive numbers. So if you notice in here, it's all positive numbers when I apply that. If I go back and turn this off and hit OK, then sometimes it's positive, sometimes it's negative, depending on the deviation values that are seen here. So format in general just allows you to format the data in the cells depending on a variable or an expression or just a number to force it to be a certain value if you're doing that for some testing purposes. Sort columns allows you to sort ascending or descending. It will sort the columns in the data set. So if I choose this, hit OK, here it's sorting the values from the smallest to the largest for those columns. And because it's doing that, the samples that each column represented no longer really applies, because for each feature here, it's simply sorting the values from the smallest to the largest, and that might be a different sample order for every row that's in this data set. So now you've lost the information about the samples that it comes from, but you're able to at least sort the values from the lowest to the highest within the columns. So you can sort that way. You can sort descending as well from the highest to the lowest. And then also the sort rows. You can sort the rows by a particular value. So in this case, I could say sort by CPK. And to first illustrate this, I'll turn that off. We'll get the regular rows back. If you notice, it's sorting from 1 and incrementing. But if I said sort rows by, say, CPK, and sort descending, that's going to sort from the highest to the lowest. It's changed the row ordering for the features because it's calculating the CPK value for each row and then giving you from the highest CPK value to the lowest within the data set. So again, all of these could be used in multiple combinations depending on what it is you're trying to sort or see within the data set. Finally, in this module, we'll talk briefly about the Statistic tab. This is used mainly in cases where you will be computing process control statistics, or they'll be given to you by the customer and put to the system for your features, and they might be using what are known as control charts. So typically, the default setting here, if I go to the Statistic tab, the type of use would be individual value. That would be, say, a trend chart where you're just looking at the ordering of the samples in time taken during some time period, and they're listed as markers within a chart, so a typical trend chart. But if the company is doing process control, then they'll probably use one of the 4 other types of statistical use, whether they want to use individual moving range chart, moving average and moving range, subgroup mean and range, or subgroup mean and sigma chart. So again, these are process control charts that a company might use to keep track of whether their process is in control or out of control. If they did use one of these types, then you could apply some of the other options here, such as data transformation. This is if they need to normalize their data, if it's abnormal, create process transformed. This is rarely used. I rarely see this used, but the options are there, and we have more detail in the help file and probably in other modules as to how these options are used. There's XMR run on side of mean rule. So if you're using a control chart option, one of these other four, you can specify for trending if the data values tend to be increasing upward or downward on either side of the mean or average. You can determine when to set an alarm based on trend of 7, of 14, or of 21. Here you can also create what's known as range of variation variables. This starts off with one that is 50%. Range of variation will let you chart or see what percentage of your values for a feature are within what's considered an acceptable range of your tolerance bandwidth. There'll be another module probably just to cover that, as there's some extensive options when it comes to range of variation and the variables that are used with it. But the option is located here within this statistics tab. Subgroups. This area allows you to specify the subgroup size depending on one of the options you've chosen. For instance, subgroup mean and range, or subgroup mean and sigma. You can specify what the subgroup size is, specify the maximum subgroup size, specify subgroup by week, by a day based on this size here, or by some identifier. So depending on one of the options, you can specify what the subgroup will be to generate your X bar or your average, and you can supply here what the size of that subgroup will be. The process control, these are checks that will allow you to see on a chart, if you're using a control chart, a type of out of control condition, whether it's limits exceeded, trending up or down, running on the side of mean or average value, 40% or less in middle third of control limits, or more than 90% in middle third of control limits. And then there's some other options with regards to something called MSA, normal distribution, or creating trial control limits. So a lot of this is used, again, if the company wants to do more than just look at maybe benchmarks or trending data, but wants to use control charts in order to track the quality of the process for their manufacturing for that part. So there's a lot of options here. Again, typically by default the individual value is moved, but you would have to choose one of these depending on the control chart type, and then work with the customer to specify what the size of the subgroup is and which process control indicators they want to see within the chart. So that's a lot of explanation for many of the basic functions within the data set. There's some others that we'll talk about later on, for instance the data stack. That'll be a different module, but everything that we've covered is, I would say, 80 to 90% of the functions that you would see within a data set. The main things to remember is SIFT rules, this first tab for general, for determining the type of data or any filtering that you want to do on the data. and then also the data source where you can connect to particular source of data, whether it's a query, looking at all the features and let the sorting or the filtering give you back just, whatever's based on your filtering criteria, or picking from the list here and choosing specifically certain features you want contained within this data set. The one thing I do want to also mention is that you have the ability with data sets to connect to other data sets as well. So you can pull information directly from the query, or if you have, say, 2 or more data sets, one could be looking at the query, and then the other could be connecting to that first data set and yet use its own sift rules or sorting mechanisms based on that data. So that's possible as well. You can chain data sets and data stacks together. So with that being said, thank you for watching this module. Hopefully the information is informative, and we will see you next time when we talk about data stacks.